Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating paper on creating flat lenses using colored photoresists and an eye-line stepper. It's a game changer for mass production, folks.
A flat lens made entirely with colored photoresist? That sounds incredibly simple. What's the big deal? Aren't flat lenses already a thing?
Oh, absolutely. Flat lenses, or metal lenses as they're often called, exist, but current fabrication methods are complex, often involving high aspect ratio nanostructures and demanding techniques like electron beam lithography. This is expensive and slow, hindering mass production.
I see. So this new method uses a simpler approach?
Exactly. This research uses a Fresnel zone plate, FZP design. Think concentric rings, alternating transparent and opaque regions. This design inherently avoids the need for those super tall, tiny structures. And the trick? They use colored photoresists, which absorb specific wavelengths of light, acting as the opaque regions. No etching needed.
So just spin coat the photoresist, expose it with a stepper, and develop it? That's it?
Pretty much. They used an eye-line stepper, a standard piece of equipment in semiconductor manufacturing. They even managed to fabricate these lenses across an entire 8-inch wafer. That's impressive scalability.
Amazing! But how well does it actually work? What kind of resolution are we talking about?
They fabricated lenses for red, green, and blue wavelengths. For the 550 nanometers green lens, they achieved a focal spot diameter of about 1.1 micrometers, and their imaging tests using a USAF resolution test chart showed they could resolve features down to that same 1.1 micrometer size. That's incredibly sharp focusing for such a simple process.
That's, remarkable. But what about efficiency? Surely such a simple method would have lower efficiency than more complex designs?
You're right to be skeptical. The efficiency is lower than some high-end metal lenses, around 7.2% at 3 times the FWHM. However, their simulations suggest that with a monochromatic light source and some design tweaks, they could reach nearly 11%. And remember, this is a much simpler, cheaper, and scalable method. The trade-off might be worth it for mass production.
That's a fair point. So what are the limitations? What could be improved?
Well, the use of a polychromatic light source in their testing slightly degraded the performance. Monochromatic light would yield better results. Also, the minimum line width of their fabricated structures was slightly larger than designed, impacting efficiency. But overall, the results are extremely promising.
It's a really clever approach. Using readily available materials and equipment to achieve such high resolution is a significant breakthrough. This could revolutionize the manufacturing of flat lenses for consumer electronics and other applications.
Absolutely. This research opens up exciting possibilities for mass-producing high-quality, low-cost flat lenses. It's a great example of how clever engineering can overcome seemingly insurmountable fabrication challenges. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll see you next time. Goodbye.
Bye-bye.